Okay, in this video, we'll talk about geometric infinite series. So let's tell the difference. What is the difference between finite? Finite means we have a certain number of the terms, 5 terms, 12 terms. If we are writing the terms like this, and we have a dot, dot, dot at the end, but we are looking for only 14th terms. Okay, here is end, right? So that is finite terms. And if we have this example, it keeps going forever and there's no direction on it, and that's called infinite series. And next one, same thing, infinite series. So this is called the geometric infinite series. And formula is different from the above. Above, we have finite geometric series formula like that. Somehow formula looks similar, isn't it? S, N here, no N here. A1, A1. We don't have that part, and we have 1 minus r in the denominator. So somehow the formula is very similar, and if I need to drive the formula, that will be the calculus level of work. So we will skip that part, but I'll talk about how we use the formula and how we see this geometric infinite series in the examples, okay? So let's look at number 7. It goes like this: 72, 36, 18, 9. What is a pattern? We have a common ratio divided by 2. So I'd like to use multiplier. It means times 1/2, right? So I want you to check the condition of this formula. This is the formula for infinite geometric series. It keeps going forever and ever. And this formula is only working when the tail gets smaller and smaller and smaller. What do I mean, tail? This is the tail of the sequence, okay? And the series goes smaller, smaller at the end. So it's going smaller and smaller. The common ratio is less than 1. When common ratio is less than 1, we can use this formula. So let's find the sum for this sequence. Sum of this sequence is the series, and it goes forever and ever, so that's called the infinite geometric series. So formula says use first number, 72. Denominator, 1 minus r. So answer will be 72, that is half, so flip it, that is times 2, right? So that will be 144. Do you really think this sequence, when you add all up, the series is converging to the number 144? What do you think? And the tail gets smaller and smaller, so it may be bounded by a number, and this number is the limit of that bounded number. So that is the idea, okay? And concept is just connected to the calculus level, and I will not go there. So let's just use the formula, okay? And check the condition. What's the condition? I can use this formula only when the tail of this sequence gets smaller, okay? If it gets bigger, there is no meaning of calculating the sum. You will have infinity, right, as sum. So it's not going to be considered as bounding or the conversion. So let's look at number 8. We have pattern on this sequence, and let's find the series. What is the common ratio? Still is taking 1/2, that's right. Is that less than 1? Yes, absolute value of r is less than 1, and then we can use this formula. So let's apply the formula. First number, 1/3. And subtract 1 minus the 1/2, and then 1/3 divided by 1/2, which is times 2 over 1. So that will be 2/3. So we are saying that this sum is bounded by 2/3, and the sum is going to be 2/3, okay? Weird, isn't it? Yeah, you will have enough time to understand this thing. Number 9, what is the difference between this sigma notation and above? You have infinity for the end, right? So it goes forever and ever. So this is the notation for geometric infinite series. So let's calculate it. Can I work on the formula? What is r? It's less than 1, so it is working, right? So let's calculate. What will be the first term? Let's plug 1 here, and half over 12 is 6. So first term is 6. And the denominator has 1 minus 1 half, which is the common ratio. So we will flip the denominator, which is 1 half. Reciprocal is 2, so answer will be 12. So this sum is bounded by 12. And that is called the sum of the infinite geometric sequence series. Question number 10, can I use the formula? I cannot, because what's the common ratio here? 3 over 2. Is that less than 1? It is not less than 1, right? It is not less than 1. So I cannot use the formula. So this one goes to infinity. It means this is divergent. So this is divergent series. And we will discuss series is converging, diverging a lot in calculus BC.